this reaction is going to be endothermic reaction or exothermic reaction. Let's actually revise again. Any kind of decomposition reaction, endothermic or exothermic, your AS knowledge, Justin. Okay, any kind of endothermic reaction, any kind of decomposition is going to be endothermic reaction. But again, if let's say I want to actually find out the rate, okay, of decomposition of calcium carbonate, Shane, what can I use? Okay, do take note that this is going to be solid, this is going to be solid, this is gas. Can I actually use change in concentration divided by time taken, Shane? What do you think? You're muted, right? Yeah, do you know that? No need to Google, Shane. Okay, just let me know. What do you think? The answer is yes or no. Can we use change in concentration for decomposition of carbonate?
Sorry, sir. I'm lagging.
Okay. Lavi, can you use change in concentration for reaction rate for this using concentration for calcium carbonate?
I think can, sir.
No. How do you actually find the change of concentration? Concentration is number of moles divided by volume, and they are all in solid.
Oh,
so
cannot.
Yeah, whenever there is gas being given out, okay, when gas is given out, apart from this, there are so many other ways that you can measure. Like for example, you cannot use change in concentration, but I can always use the change in mass. Change in mass of calcium carbonate over time. Okay, so this one is not limited only for change in concentration. So it can be also change in volume of carbon dioxide or any gas divided by the time taken. So the idea is whatever that is being changed, divide by time. That is going to be rate of reaction. Okay, so here they're asking you to convert, okay, the following rate in moles per dm cube per second. I think this one is very easy. Okay, why very easy? Because I think it's just simple conversion. It's like when you have something in gram, okay, you just need to change it into moles. Okay, so find out the number of moles. Okay, and then you are going to actually okay, you can see here what they have done. Okay, they find out, okay, 0.254 is the mass. Okay, I2. Okay, they look from the periodic table, 127 times 2. So you will get the number of moles. Okay, once you get the number of moles, okay, it's not reflecting on my screen. Okay, just wait for a while. Maybe it's lagging.
Sir, I think you're muted.
Yes, I'm muted. Okay, sorry. So again, what I was actually talking about, okay, basically you find out, okay, find out the number of, in this case, they say gram, and then the volume, okay, in dm cube. So first find out the concentration. So once you actually find out the concentration, so you will actually get the concentration as, this is moles, okay, divided by 1 dm cube in 1 hour. So you can change, okay, into the rate according to the formula, time taken, In this case, they change it into per second. Okay, so they wanted it in per second. So you change 1 hour into seconds. Okay, they have done it there. Then you get the answer over there. The same thing applies over here. Okay, when you have certain this ester, okay, being formed in 1 minute, okay, from a mixture volume of 400 cm cube. So what we need to do is just change it into the number of moles first, and then they say in 1 minute. Okay, I think this one is actually wrong. Yeah, it's 1 minute. Okay, 1 minute. So volume is going to be 400 cm cube. So you need to actually take the number of moles. Okay, 400 cm cube is 0.4. Okay, this one, if you don't understand, you just times with 0.4 dm cube. I'm laggy again. Okay, anyway, so you see, I'll put it here. So concentration is going to be divided by 0.4. Yeah, so this one is 5 times 10 negative 4 divided by 0.4. Whatever it is, you are going to get this in 1 minute. Okay, once you actually get that in 1 minute, okay, my connection is not stable. Okay, let me check again. Nicole, can you hear me? Can you guys hear me? Can you guys hear me now? Okay, so I'll continue. So here, okay, they mentioned that in 1 minute. Okay, so just now was 1 hour, is wrong. Yeah, so it's 1 minute. So 1 hour, okay, again, I think it's 1 minute again. This is also wrong. It's all taken from your textbook. Okay, the answer from the textbook. So you just change it into seconds, okay, divide, and then you will get the answer. Something like that. Okay, all these are taking into consideration if you are using the formula rate of reaction as change in concentration divided by time. Okay, but do remember they are not limited to this formula alone. Okay, they are not limited to this formula. It can be also change in volume divided by time taken. But again, you can see rate of reaction or any kind of when you have rate, it means something divided by time. Okay, something divided by time. So that something, it can be either concentration, it can be also mass, it can be also volume of the gas, okay, being produced. Okay, and normally the time that we are going to use, the unit is per second. Okay, so seconds, you need to change it into seconds. Now, so there are going to be some methods. Okay, this one is given in the textbook. There are some methods for following a cause of reaction. Like for example, okay, if you have A reacting with B and to give you C plus D, okay, there are ways to actually find out, okay, the reaction. Let's say this reaction is going to proceed. So I can actually use two methods. One method is called sampling method. Another method is called continuous. Let's actually look into what is meant by sampling method. Okay, sampling method. Now, sampling method is going to be, we are going to take small sample of the reaction mixture at various time. Okay, so it means like, for example, if you have A plus B to give you C plus D, I'm going to take, okay, a small sample of the mixture. It means maybe after I put, okay, I put in A and B, okay, A plus B to give you C and D. Okay, I will actually take, okay, a small sample, okay, at T equals to 30 seconds. Okay, I will take. Then after that, I will take another small sample when T equals to 60 seconds. Let it react. Okay, while reacting, then I'm going to actually take another sample. Okay, T equals to 90 seconds. It means I'm going to use a small sample of the mixture at various time, and I'm going to do chemical analysis. Why chemical analysis? So of course I want to find out whether this thing is going to be C or D. I need to fix. Okay, because when I want to actually find out rate of reaction, I need to change, maybe is it decrease in A or decrease in B, or is it going to be increase in C, or is it going to be increase in D? So I will do whatever required, okay, whatever analysis required to find out, okay, in this sample that I took, because they have A, B, C, D, if I can find out, and when I do analysis, I can find out the amount of D, okay, the amount of D that is going to be formed, then I can actually use that concentration, okay, and then I can actually use the time that I have over here. Then I can actually find out and plot the data or plot the graph. Okay, so in order to do that, okay, because when you do chemical analysis, it takes time. Like for example, okay, when I use my stopwatch, okay, I use, okay, when I say 0 to 30 seconds, now it's going to be 30 seconds. I'm going to take a small sample. Okay, maybe I take 1 ml sample at 30 seconds. And before I do the chemical analysis, time is still ticking, right? It's still running. Okay, so the reaction is still, as time is running, okay, before I add or do chemical analysis, the reaction will still going on. So that 30 second will become like invalid. So what I need to do, when I take this small sample, the 1 ml, okay, I will actually put it in a test tube. And I am going to actually quench the sample. This is the sample, the 1 ml sample at 30 seconds. And I am going to quench the sample to stop or slow down the reaction. Okay, I will actually try to slow down the reaction, because if I just leave it like that, the reaction will continue. So there are some methods that we can use to quench the reaction. One of the example is by cooling the sample in ice. Why cooling the sample in ice? Because we know when you decrease the temperature, the rate of reaction will go down. Okay, rate of reaction will go down. So this is one of the method that we make sure, okay, that the reaction is going to not continue. Okay, so we will have sample 1. Then I will do the sample for 60 seconds. Okay, then I will actually put them in a sample of ice. Then I'm basically I'm going to quench all of them. Okay, and I'm going to actually do chemical analysis, CA. Okay, chemical analysis to find out, okay, what is there. Like for example, if you have this example, okay, when this reaction reacting with OH minus, okay, let me actually see whether you guys are alert or not. Okay, Nicole, Trisha, what type of mechanism is this reaction? It's a halogenal alkane. Halogenal alkane will undergo what kind of mechanism? You have so many mechanisms: free radical substitution. Free radical substitution. What else? Electrophilic addition. Electrophilic addition. What else? Lavi?
Nucleophilic substitution.
Nucleophilic substitution. Nucleophilic addition. Okay, when we learn about benzene, yeah, nucleophilic addition. Okay, so in this case, which one will be the best answer, Nicole, Trisha? Do remember, alcohol and halogenal alkane, they will undergo nucleophilic substitution reaction. Yeah, take note of this. So this one is nucleophilic substitution. Okay. If nucleophilic substitution, then you need to know whether they are SN1 or SN2. Okay, please go and revise on this. SN1 is always for tertiary halogenal alkane. SN2 is always for primary halogenal alkane. So here, if you look at C4H9Br, okay, this one is not a structural formula. Okay, but if let's say we just follow like normal, okay, if Br comes here, Is this primary or tertiary, Charlton?
Primary.
So if it is primary, they will undergo SN2. Okay. So if SN2, it means are they going to actually form carbocation or are they going to actually form intermediate? Aneta? Normally do remember if tertiary, if you have more alkyl groups, okay, the positive inductive effect is more. Okay, so the carbocation, the tertiary carbocation will be more stable. Okay, so carbocations will be formed. So in this case, if you form, if you follow SN2, we are going to actually follow the intermediate. So it means 5 bonds will be formed. Then after that, one of the bond will be broken. Okay, please actually go through this. I have actually 2 years ago, I've actually created a video on this. Okay, SN1 and SN2 mechanism. Please go through that video in YouTube. Okay, anyway, okay, so you have this. Okay, so let's actually come back to this reaction here. What we can do, okay, to see, okay, like for example, when we take this sample, okay, when we take this sample, we are going to have so many things over there. So I can actually use chemical analysis to find out, okay, like for example, what is going to be the concentration of Br, for example, okay. So can Gabriela, Nicole, can you actually suggest what might be the suitable chemical analysis that we can use to calculate reaction rate of this reaction? What do you think? Just suggest. Just anything that comes in your mind.
Mass.
Mass. Why mass? Actually, no need mass. You know, you already learn about, okay, if I use silver ions, okay, it means when I actually add with silver nitrate, they will actually react with these halogen halide ions. They will give you silver bromide. Can you remember this? Silver chloride, silver iodide. Can you remember? So if you have, yeah, if you have Br minus there, if I add silver nitrate, okay, if I add silver nitrate, I am going to get a precipitate. To be exact, a cream precipitate will be formed. If I can actually find out, okay, the precipitate, if I can find out how fast the precipitate is being formed, okay, then I can actually somehow relate it with the rate of reaction, okay, or if I can actually calculate what is going to be the concentration, okay, of using, let's say, Ag silver nitrate, if I can actually calculate what is going to be the amount of silver bromide that is being formed, yeah, you can actually do that as well. So this is where the chemical analysis will come, okay. Or sometimes we actually use the rate of reaction, how fast, like for example, when I do this, you can actually put a white piece of paper and put an X over there, okay, and then you put a beaker, okay, and then it will be cloudy, right? So when the X is going to disappear, it means totally cannot be seen, okay, that is going to be can be used to identify the rate of reaction. I'm just thinking forward, yeah, I'm just thinking more, okay. Please actually think more about this, how they can actually use all the things, all the information that you have learned, how can you use them to do analysis, okay. But the concept is still the same. This is going to be a sample taken from time to time, okay. And when you take this sample from time to time, you need to quench the reaction. You need to slow down the reaction by using a sample, put the sample into ice, okay, something like that. So this one is going to be sampling. Let's actually take a look at continuous, okay. What is continuous method? Continuous method is we do not need to take it one by one. We let the reaction continue and we just take the reading. So it means we are going to monitor that over a period of time. Okay, like for example, you can actually use colorimetry. Colorimetry is different than calorimetry. Okay, colorimetry means it's going to actually identify changes in color. Okay, changes in color. So you can use colorimetry. You can use conductivity meter. Okay, it means if you are forming free ions, okay, like even like in the previous slide, okay, if you are forming free ions, okay, but ions and ions, I think you cannot use electrical conductivity. But if you're using electrical conductivity, let me actually see, like this example, you can see that they are covalent, but they are producing something that can conduct electricity. So it means that electrical conductivity will be more as the reaction proceeds. Okay, so you can actually use these methods, okay, or measuring changes in volume or pressure of gas. So whenever you set this experiment and then you want to find out the volume of gas being produced over time, you don't need to do the sample one by one. I think continuous is much more easier. So it means for T per 30, I just need to actually find out how much is there. Maybe T 30, 60, I might actually have over there. So I just do it continuously. I no need to do sampling. Okay, that is continuous method. So colorimetry, how we can actually use colorimetry. You see, what is the color of iodine? Iodine is normally in solid form, but in this case, I think they are mixing it with okay, this one is going to be ketone. So they are going to mix ketone with iodine, and you are going to get something like this. Okay, so in this case, let's actually find out whether you can understand what is the type of reaction that is taking place over here. Okay, let's just see. Victoria, what do you think the mechanism of the reaction that is going to take place here? What type of reaction is taking place? Use your AS knowledge. One of the H is replaced to become I, and then there's HI. Don't you think it's similar with this?
Is it addition?
No. This is free radical substitution. Of course, they are not talking about alkanes, but they are talking about CH3. The carbon and H is going to be substituted by I. So this reaction will happen under the presence of UV light. Take note of this. Yeah. So this one, okay, we can actually, they will give you different examples. I think this one you need to think, apply, start applying. Okay, unless we are actually putting something over here at this carbon, then it might be different. But in this case, it's carbon to the hydrogen. So this is reaction of alkane. So reactions of alkane can happen in any compound. Okay, so this is free radical substitution. Okay, in this free radical substitution, we know that, okay, iodine. Okay, iodine in this case, it must be in liquid form. Okay, so whether it's liquid form or not, okay, or gas form, okay, what is the color of iodine? Yeah, so do remember, if iodine in solid, I2 in solid, the color is black. If I2 is going to be in gas, or I2 in form of liquid, I think it's more towards liquid is brown, gas is going to be purple. Okay, so in this case, I do not know whether it's going to be liquid or gas, but again, if it is UV light, I'm assuming it's going to be gas, because this one must be in gas. Yeah, so this one, if I assume is a gas, it means the purple color, this is purple. So the purple color is going to become colorless. So it means the purple color will become less, the intensity of the purple color will be lesser. So when the intensity is less, okay, so that's why the color of iodine fades. Okay, so if we can use a colorimetry, colorimetry is going to measure what is going to be the intensity of the color? It means previously, let's say, just take it. I do not know. I never used colorimetry before. But let's say the intensity was 100%. But now it's going to change slowly to become 0%. So I can measure from a time interval from, let's say, 100 become 90%. What is the time? Okay, if I can set a particular time interval, I can actually use colorimetry to identify or to find out the rate of reaction. Another method is going to be by using conductivity method. I already told you, if you have free moving ions being formed, okay, you can use electrical conductivity to show, yeah, previously no electrical conductivity. Now the electrical conductivity is going to increase, okay, over time. So I can use that graph, okay. So can be used even, okay, the reactant have ions. It means they have ions, okay, you can use the electrical conductivity. Okay, if let's say there's ions that don't have ions, like for example, Ag plus Cl minus to give you AgCl. This one, you can actually, this is free moving ion to form solid. So it means the electrical conductivity will decrease. So you can do that also. You can still use the conductivity meter. Okay, changes in pressure and volume. So every single time that is involving gas, the best method, okay, to measure, okay, like the one that I mentioned about calcium carbonate give you calcium oxide plus carbon dioxide. The best method whenever it comes to gas, please use the changes in volume of gas. It means you need to use the gas syringe. That is the best method, which is this one. This is the best method whenever there is going to be, if you are going to use to find out the rate of reaction. So in this case, you see, I hope you understand about the continuous and sampling. You see, there's another one, dialectometer. Okay, so the dialectometer is used to find out small changes of volume. Okay, so if you have changes in volume, they can actually use that. But this one, I never seen this device. Okay, but again, this is one of the way. It's actually given in the textbook. Okay, so there are so many methods. Okay, but you need to actually learn how to differentiate sampling method. Okay, sampling and then continuous. Okay, so maybe someone can summarize sampling and continuous. Shane, can you summarize about sampling and continuous based on your understanding?
If continuous, like use measurement, like devices.
Is sampling?
Sampling.
We also use devices.
Yeah.
No, actually we don't use so much on, we don't rely on devices. We will use what? Chemical analysis. For sampling, we use chemical analysis. But important thing about sampling, can you elaborate further? Maybe Charlton can help. Charlton, can you elaborate more on the sampling?
If sampling, take sample from different times.
Okay.
But must be stop the reaction.
Yeah.
Because
So
time
that
is
what is
ticking.
the? How do you stop the reaction? The term that you need to use is what?
Quenched.
Okay. Okay. So this is the term quench. So this term, how do you quench the reaction? How do you stop the reaction?
Cooling with ice like that.
Yes, we use by cooling it with ice and so on. Okay, so this one, that is actually about sampling, small sample with a certain duration of time. Continuous is we don't take out the sample, we just measure or monitor throughout the reaction. Okay, so we actually just monitor, we don't need to take out anything. Okay, just a collection of gas like colorimetry, okay, to find out the changes in color, or if you can use the electrical conductivity. Okay, so you can actually see whether they are going to conduct electricity or not. Yeah, that is going to be another method. Small changes of volume, dialectometer will be one of the methods. So you have total of 4 methods here. Okay, colorimetry, conductivity meter, and then this one, number 3, by using gas syringe, and by using dialectometer. 4 methods. Okay, take note of this.